The Atlantic Ocean is a place of profound indifference. It is a wilderness of wind and water that covers 20% of the Earth's surface, a chaotic system where the difference between survival and oblivion is often measured in degrees of temperature or shifts in barometric pressure. But within this vast expanse, there lies a specific geometric abstraction that has captivated the human imagination for nearly a century. It is drawn between 3 points: Miami, Florida, San Juan, Puerto Rico, and the island of Bermuda. 500,000 square miles of open ocean. On a map, it is nothing more than a shipping lane, a heavily trafficked corridor of commerce and tourism. In the collective consciousness, however, it is something else entirely. It is a graveyard. The legend officially began on a clear afternoon in December 1945. Flight 19, a squadron of 5 TBM Avenger torpedo bombers, took off from Fort Lauderdale for a routine training mission. They never returned. The rescue plane sent to find them never returned. 14 airmen and 13 crew members vanished into the ether, leaving behind only static and a final disorienting radio transmission. We don't know which way is west. Everything is wrong. Even the ocean looks different. Since that day, the Bermuda Triangle has become synonymous with the inexplicable. It is the canvas upon which we project our fear of the unknown tailies of rogue waves, magnetic vortices, and electronic fog. But stories are not evidence, and fear is not data. To understand what is truly happening in this stretch of the Atlantic, we must strip away the mythology. We must look past the paranormal and stare directly into the physics of the ocean. We are not looking for monsters. We are looking for the truth behind the disappearances. This is an autopsy of the Bermuda Triangle. The statistical paradox: to define the mystery, we must first define the boundaries. Connect the points between Miami, Bermuda, and San Juan, Puerto Rico, and you enclose roughly 500,000 square miles of open ocean. To the cartographer, this is simply the western North Atlantic. To the cultural consciousness, it is a zone where the laws of physics seem to fray, a graveyard for the lost. But the reputation of the Bermuda Triangle presents a difficult paradox. This is not a desolate, forgotten corner of the globe. It is one of the busiest maritime and aerial crossroads on Earth. Every day, massive container ships navigate these waters bound for the ports of the Americas and Europe. Cruise liners carrying thousands of passengers cut through the swells, and commercial airliners crisscross the airspace above with routine precision. The central question, therefore, is not merely why vessels vanish, but whether they vanish here with any greater frequency than in any other volatile stretch of ocean. Does this geometric abstraction harbor a specific localized lethality? Is there a genuine anomaly buried in the data, a unique force that plucks planes from the sky and drags ships to the seabed? Or is the triangle a fabrication of human psychology, a pattern imposed upon randomness? When a ship sinks in the Pacific, it is a tragedy. When a ship sinks here, it becomes a myth. To understand the truth, we must strip away the supernatural veneer and examine the cold mechanics of the sea itself. We must determine if the danger lies in the coordinates or in our interpretation of them. To understand why vessels vanish, one must look past the horizon and peer into the bathymetry below. If we were to drain the Atlantic, the landscape revealed within the triangle would be one of violent extremes, a topography as dramatic and treacherous as any mountain range on dry land. The region is defined by a geologic schizophrenia. Around the Bahamas, the waters are deceptively shallow, a turquoise plateau of sandbanks and coral reefs where navigation requires absolute precision. But mere miles from these shoals, the ocean floor collapses. The continental shelf does not slope gently. It shears off into the abyss. In the southern reaches of the triangle lies the Puerto Rico Trench, the deepest point in the entire Atlantic Ocean, plunging nearly 28,000 feet down. When a ship or aircraft sinks here, it does not simply come to rest on a sandy bottom accessible to divers. It falls into a midnight zone of crushing pressure, tumbling into canyons that rival the Grand Canyon in scale. In these depths, the evidence of a disaster is effectively swallowed by the Earth itself, placing wreckage far beyond the reach of standard search and rescue sonar. Complicating this vertical danger is a horizontal force of immense power, the Gulf Stream. This is not merely a current. It is an underwater river, 40 miles wide, surging northward with a velocity that can exceed 5 knots. It functions as a massive, relentless conveyor belt. A pilot who ditches a small aircraft in these waters faces a terrifying reality. The position of impact is almost instantly irrelevant. Within hours, debris can be carried dozens of miles from the crash site. By the time rescuers arrive at the last known coordinates, the ocean has already scrubbed the scene clean, moving the evidence into the vast anonymity of the northern Atlantic. Above the surface, the environment is equally volatile. This patch of ocean sits at a convergence zone where warm, tropical air masses collide with cold fronts pushing down from the continent. The result is a weather system prone to rapid, violent destabilization. Thunderstorms here are not always forecasted. They can materialize with explosive speed, creating localized white squalls, intense downdrafts capable of capsizing small vessels or swatting low-flying aircraft out of the sky before dissipating just as quickly, leaving behind blue skies and a baffling silence. If the ocean floor provides the stage for disaster, the water and air above provide the violent choreography. The Bermuda Triangle is not merely a static area of the map. It is home to the Gulf Stream, an oceanic current roughly 40 miles wide that functions as a river within the sea. It circulates warm water from the Gulf of Mexico into the North Atlantic with a velocity that can reach 5 knots. In this hydrodynamic engine, a vessel in distress is not stationary. It is on a conveyor belt. A debris field from a crash can be displaced by hundreds of miles in a single day, turning a precise search grid into a futile exercise in probability. This current does more than move water. It drives atmospheric instability. As the warm, humid air rising from the Gulf Stream collides with cold, dry air masses pushing down from the continent, the result is an explosive thermodynamic reaction. Meteorologists have long documented the region's propensity for white squalls, sudden, intense downdrafts that strike without the warning of looming storm clouds. These microbursts hit the surface with the force of a detonation, capable of capsizing small craft or shearing the wings off low-flying aircraft before a distress call can even be keyed. Compounding these physical threats is a phenomenon that has plagued navigators since the voyages of Christopher Columbus: magnetic variation. The triangle is one of the few places on Earth where the agonic line, the imaginary boundary where true north and magnetic north align, has historically passed. For the inexperienced pilot or sailor relying on a magnetic compass, a failure to calculate for the shifting variation between these 2 points can result in a subtle, creeping navigational error. Over the course of several hours, a deviation of just a few degrees leads a vessel hundreds of miles off course, pushing it further into the open ocean, far beyond the reach of fuel reserves and rescue. Here, science suggests that the mysterious force pulling ships astray is not paranormal, but a fundamental misunderstanding of geomagnetism. Section 5. The fragility of perception. While the physical world creates the hazard, the catalyst for catastrophe often lies within the cockpit itself. We search for magnetic anomalies or rogueways, yet we frequently overlook the most volatile component in any vessel, the human operator. In the vast, featureless expanse of the Western Atlantic, the greatest enemy is often not a supernatural force, but the physiological limitations of the human mind. Pilots call it spatial disorientation. It is a sensory betrayal where the brain can no longer distinguish up from down. Under normal conditions, an aviator relies on the horizon to maintain equilibrium. But in the triangle, unique atmospheric conditions often blend the azure ocean with the haze of the sky, erasing the horizon line completely. Without this visual anchor, the inner ear of the vestibular system begins to supply false data. A pilot may feel they are flying straight and level when they are actually in a slow, subtle bank. If they trust their instincts over their instruments, they risk entering what is grimly known as the graveyard spiral. As the plane banks, lift is lost and the nose drops. The pilot, sensing the descent, but not the turn, pulls back on the yoke to climb. However, in a banked attitude, This action does not gain altitude. It tightens the turn and increases the G-force, accelerating the aircraft toward the water in a fatal arc. This psychological collapse explains why so many final radio transmissions from the region feature confused pilots reporting that the ocean looks strange or that the compass is wrong. They are not necessarily witnessing a warping of physics. They are experiencing the terrifying disintegration of their own spatial awareness. In these moments of high-altitude panic, the Atlantic does not need to be violent to claim a victim. It simply needs to be silent, featureless, and waiting for the mind to fail. Nowhere is the intersection of human fallibility and oceanic indifference more hauntingly illustrated than in the events of December 5, 1945. This date marks the genesis of the modern legend, yet the reality of Flight 19 offers a narrative far more chilling than the myths that followed. 5 TBM Avenger torpedo bombers took off from Fort Lauderdale on a routine navigation exercise, carrying 14 airmen into clear skies. They never returned. The disappearance of Flight 19 is often cited as the ultimate proof of paranormal activity, but a forensic analysis of the radio transcript reveals a slow-motion descent into confusion. Lieutenant Charles Taylor, the flight leader, became convinced his compasses had failed. In the grip of spatial disorientation, he believed he was over the Florida Keys, miles off course. Despite the pleas of his subordinates, who correctly sensed they should fly west toward the mainland, Taylor ordered the formation further east, deeper into the Atlantic void. The horror of Flight 19 is not in the silence, but in the noise. For hours, radio operators on the ground listened to the squadron's disintegration. They heard the fraying of discipline, the rising panic in young voices, and the agonizing debate over direction as fuel reserves dwindled. The sun set, the weather deteriorated, and the ocean below turned into a black, indistinguishable abyss. The human cost was compounded when a PBM Mariner rescue seaplane, dispatched to search for the Avengers, also vanished. 13 crewmen were aboard. Reports from a passing tanker confirmed a mid-air explosion, attributing the loss to a known mechanical flaw in the aircraft rather than a mystery of the ether. In a single night, 27 men were erased. The controversy that persists ignoring the documented confusion and mechanical failure in favor of sensationalism does a disservice to the terrifying reality of their final hours. They were not taken by forces unknown. They were claimed by the dark, cold physics of a fuel tank running dry over an unforgiving sea. Section 7. The mechanics of disappearance. The narrative of the triangle often privileges the aviator, the lone figure battling the clouds. But the Atlantic does not discriminate by altitude or tonnage. While Flight 19 birthed the modern legend, the true scale of the region's menace is best measured in steel and displacement. Before the airmen vanished, the ocean had already claimed leviathans, incidents that stripped away the comfort of size and engineering. Consider the USS Cyclops. In March 1918, this collier of the United States Navy, a vessel over 500 feet long, departed Barbados for Baltimore. She was carrying 10,000 tons of manganese ore, a cargo significantly denser than coal. When loaded improperly, such weight lowers the center of gravity to a dangerous degree, causing the ship to snap back violently from rolls and rough seas. Somewhere in the Straits of Florida, the Cyclops simply ceased to exist. She sent no distress signal. She left no oil slick. 306 crew members and passengers were erased from the roster of the living, marking the single largest loss of life in U.S. naval history not involving combat. Decades later, in 1963, the SS Marine Sulphur Queen followed a similar trajectory into oblivion. A converted T-2 tanker carrying molten sulfur at high temperatures, the ship was a floating chemical hazard. Investigations later revealed a history of fires around the cargo tanks and a structural constitution weakened by corrosion. When she vanished off the coast of Key West, investigators found only life jackets and a foghorn. The controversy here is not supernatural, but industrial. These ships likely did not disappear because of a vortex, but because of a catastrophic, instantaneous structural failure, a hull splitting in two, or a cargo explosion that left no time for a radio operator to tap out a final plea. The true horror of the triangle is not that it defies the laws of nature, but that it executes them with such ruthless efficiency. In deep water, a sinking ship does not always leave a marker. The Gulf Stream acts as a conveyor belt for debris, sweeping away the evidence of tragedy before search teams can deploy. For the families left behind, this geological efficiency creates a unique form of purgatory. Without wreckage, there is no body. Without a body, there is no funeral. The disappearance becomes a suspended state, an open wound where the scientific reality of a hull fracture competes with the desperate hope for a miracle. The triangle, in this sense, is an architect of grief, hiding its victims in a darkness so absolute that it forces the human mind to invent monsters just to fill the silence. There exists a profound dissonance between the legend of the Bermuda Triangle and the cold, hard calculus of maritime economics. If the region were truly a supernatural vortex, a zone where the laws of physics were routinely suspended, the first to notice would not be paranormal investigators, but actuaries. The global shipping industry operates on risk assessment. Yet, within the ledgers of Lloyd's of London and other major insurance underwriters, the Bermuda Triangle does not exist as a distinct entity. Vessels traversing these waters are not charged higher premiums. They are not flagged for exceptional hazard. To the unsentimental eye of the global economy, a ship sailing from Miami to San Juan faces no greater statistical probability of ruin than one navigating the North Sea or the Sea of Japan. The numbers simply do not support the nightmare. Why then? Does the myth endure with such ferocity? The answer lies in the human intolerance for the unexplained. We are a species that demands causality. When a massive freighter like the Asterisk, S Marine Sulfur Queen Asterisk, evaporates without a distress call, the vacuum left behind is too terrifying to remain empty. We fill it with magnetic anomalies, time warps, and extraterrestrial interventions because even a terrifying answer is preferable to the indifferent silence of the ocean. However, this industry of mystery extracts a heavy toll. By transforming these tragedies into entertainment or speculative fiction, we inadvertently dehumanize the victims. The crews of the Asterisk Cyclops Asterisk, the Asterisk Star Tiger Asterisk, and the countless fishing vessels lost to the Gulf Stream are stripped of their humanity and reduced to plot points in a science fiction narrative. For the families left behind, the triangle is not a parlor game or a riddle. It is an open wound. The specific horror of a disappearance at sea is the lack of finality. There are no bodies to bury, no wreckage to mourn over, and no black boxes to explain the final moments. The ocean absorbs the evidence, leaving the bereaved in a state of perpetual suspension. When the world clamors to attribute these losses to the paranormal, it denies the families the dignity of a natural tragedy. It suggests their loved ones did not simply die in a storm, but were taken by something other. In the shadow of the myth, the human cost is obscured, and the quiet grief of the living is drowned out by the noise of the legend. Section 9. The Digital Horizon. We inhabit an age where the concept of being truly lost has become increasingly foreign. The modern Atlantic is no longer the silent void that swallowed Flight 19 or the USS Cyclops. It is a space crisscrossed by invisible tethers, digital handshakes between shipboard transponders and orbital satellites. The global positioning system has mapped the chaotic waves into precise grids of latitude and longitude, ostensibly banishing the unknown from the bridge and the cockpit. Yet the triangle resists total demystification. The danger has merely evolved, shifting from the navigational blindness of the analog era to the dangerous complacency of the digital age. Modern sailors and aviators often venture into this volatile corridor armed with the certainty of technology, believing that a screen offers immunity against the elements. But the ocean remains unimpressed by our sensors. The tragedy of the cargo ship El Faro in 2015 serves as a grim monument to this modern reality. This was not a wooden schooner from the 19th century, but a 790-foot merchant vessel equipped with advanced weather tracking and communication sweeps. When it sailed into the teeth of Hurricane Joaquin near the Bahamas, it was not abducted by supernatural forces. It was physically battered, overwhelmed by water ingress, and silenced by the crushing physics of the sea. The difference is that today we can recover the voyage data recorder. We can hear the final conversations. The mystery of what happened is replaced by the horror of knowing exactly how it ended. This is the future of the region. As climate models predict more frequent and intense cyclonic activity in the Atlantic basin, the waters between Miami, Bermuda, and Puerto Rico will likely become more kinetic, not less. The risk is no longer about vanishing into thin air. It is about the limits of engineering when pitted against an increasingly energetic atmosphere. The silence of the past has been replaced by a deluge of data, but the outcome for the unprepared remains identical. The triangle is no longer a gap on the map, but a testing ground where our technological hubris meets the absolute, unyielding power of nature. Ultimately, the Bermuda Triangle is a psychological artifact as much as a geographical location. Over the decades, rigorous inquiry has stripped away the supernatural veneer, systematically dismantling the need for extraterrestrial intervention or ancient curses to explain the vanished. We have replaced sea monsters with microbursts, magnetic anomalies with compass variation, and time warps with the brutal, non-negotiable physics of rogue waves. The resulting reality is less romantic than the myth, but it is infinitely more formidable. The demystification of the triangle does not render the region safe. It merely clarifies the nature of the threat. The danger of this patch of the Atlantic will not diminish with time. As climate patterns shift and ocean temperatures rise, the kinetic variables that define this region, the heat energy fueling hurricanes, the velocity of the Gulf Stream may become even more volatile. The ocean does not require a paranormal explanation to be deadly. It simply requires a momentary lapse in vigilance. We cling to the legend of the triangle because it imposes a narrative structure on the chaos of death. It is comforting to believe that a ship disappeared because it entered a forbidden zone, rather than accepting that it was simply overwhelmed by mechanical failure or pilot error in a vast, uncaring wilderness. The legend makes the loss feel significant, rather than random. When we stare into the blue expanse between Miami, Bermuda, and Puerto Rico, we are not looking at a portal to another dimension. We are looking at the raw, indifferent power of the natural world. The ships and planes that rest in the silt below are not victims of a curse. They are casualties of a planet that was not built for our convenience. The true wonder is not that so many have vanished, but that, given the fury of these waters, so many continue to return, challenging the horizon, knowing that the sea always claims its due.